All right, here we go. This is chapter, what did I say this was? 8. Chapter 8. This is sine, cosine, tangent stuff, all right? And that's what this is right here, this part right here. Again, make sure you look at the first part of chapter 8 because we went through every single problem up to number 13, and now we're just finishing this up right here. So it says find the sine of A. Now these are really, really quick and easy. You don't have to actually find what angle A is equal to. You just have to find the sine of A. So here's angle A right here. Let's make this a little bit bigger so it's a little easier to see. That's a little better, isn't it? All right, look at this. It says find the sine of A. So what over what is the sine? Opposite over hypotenuse. So katoa. Remember that? So the sine of A is equal to the opposite. Here's A. What's the opposite? 12. All right. Over what? Hypotenuse, which is 15. And you should simplify it. 3 goes into both of those. 4 what? 5. That's how you should write it. If you kept it 12 over 15, I'd give it to you. But look what it says. Write it as a what? Jesse. It says write it as a what? I just underlined it. Come on, talk to me. As a fraction. That's right. Write it as a fraction. I had people putting 0.8 on there. Is that a fraction? No, it's not. So write it as a fraction. Follow the instructions. Okay, it's not that difficult. Just read it. Do what it says to do. Don't put it into a calculator. Don't just keep it like that. 4 over 5. Or you could keep it 12 over 15, but it's better if you put 4 over 5. Let's do the C. So the tangent of C. Well, C, well, let's talk tangent. Tangent is what? Opposite over adjacent. Right, so this one is what? 9 over 12. Do we keep it like that? We shouldn't. What goes into both of those? 3 goes into that, 3 times into this, 4 times. Keep it like that. Got it? I had some people put 0.8. Why would they put 0.8? Well, because 3/4 is what? No, it's not. It's point what? 0.75, right? And they rounded 0.75 to 0.8. All right. I mean, it's 2 things wrong with that. Okay, first, they didn't write as a fraction. Secondly, if it's 0.75 and it ends at a 5, if it ends in a, I mean, if it just goes 2 decimal places, just keep it 2 decimal places. But it says write it as a fraction, so you need to write it as a fraction. I will be. Now, watch my video on this from earlier, like this stuff right here. On the test when you first took it, I kind of let you get away with a little bit. Some people didn't write these exact and simplified. Some people wrote them as decimals, even though it specifically says what? No decimals. And I still had people writing answers as decimals right here. On the final, I will not give you credit if it's not exact and simplified. All right, I go through how to simplify them on the YouTube video, so it's up to you to go back and look at it. All right, let's keep going. And it says find x. Find the side to the nearest tenth and the angle to the nearest degree. All right, so let's do this. Can we just use Pythagorean theorem here? No, because you're trying to solve for a side. You only know one side. You don't know all the sides, so you can't use Pythagorean theorem. I mean, maybe you were one of them, but I had people trying to use law of sines on this thing, or law of cosines. You don't need to do that stuff. What kind of triangle is this? It's a right triangle. If it's a right triangle, use your basic trig functions. What are your trig functions? Sine, cosine, tangent. So let's see which one we're going to use. Here's the angle, and let's see the 2 sides that they give us. They give us this one and this one. So what do we have? We got opposite and we have adjacent. So I'll just write it down here. So the tangent of the angle, right, 37 degrees, is the opposite over the adjacent. So opposite is x, adjacent is 7. All right? Use the trig function when it's a right triangle. So you use a trig function on this one, a trig function on this one. Could we use a regular trig function on this? No, because it's not a what? It's not a right triangle. Okay? So only use the trig functions on right triangles, but make sure you use them. Now, you could actually use the law of sines on this, but I don't think it's a good idea. I think it's better to use the tangent. So multiply both sides by 7, and then let's plug that in. We got some time, so I'll put them in the calculator here. Let's get rid of all that mess. All right, 7 tangent of 37. So 7 tangent 37, and that's that. 5 point what? It says round to the nearest what? Tenth. So what's the nearest tenth? 0.3. 7 rounds a 2 up to a 3, so it's 5.3. And really, there's no other answer that I should accept except for 5.3. That's it. It's about the only way you can do this thing. All right? Okay, let's do this one right here. We're going to find an angle this time. And they give you two sides. So don't do Pythagorean theorem to find this. There's no reason to. You're finding this angle. So look at our sides. What trig function are we going to use with this? Okay, I've got adjacent, which is the 4, and I got hypotenuse, which is 10. Which one uses adjacent hypotenuse? The cosine. That's right. It's the cosine. Cosine of what, though? Of x, right? Because I don't know what the angle is. That's what I'm trying to solve for, so it's the cosine of x. Equals the adjacent, which is 4, over the hypotenuse, which is 10. That's supposed to be a 4. It's kind of weird looking. All right? So here we go. We got to solve for x. How do we get x by itself? How do we get rid of a cosine? The inverse. That's right. We've said this over and over and over again, haven't we? All right? Take the inverse of the cosine. Well, if I take the inverse of the cosine here, that goes away. But now I got to take the inverse cosine of the other side. Remember how to show that? What's our notation? Cosine to the negative first. That's the inverse notation. And then you just put 4 over 10. Plug that into a calculator, and you get your answer. So let's do that. Let's put 4 over 10. 4 divided by 10. Actually, let's just do it all in one shot. Inverse cosine. Second function cosine of 4 over 10. It's the best way to do it. There you go, 66.4. But this is an angle, isn't it? We're solving for an angle right here. What do we do to the angle? It says to the nearest what? To the nearest degree. So do I put 66.4? I just put 66 degrees. That's it. So x is just 66 degrees. Because it says round it to the nearest degree. And that's the nearest degree. Don't put 0.4 because that's a decimal. We want the nearest degree. We good with that? It's pretty simple, isn't it? Let's do this one right here. Now we're not going to use a regular trig function on this because it's not a right triangle. So look what we have. We're trying to solve for this. Look for that. When I watched one YouTube video, they call this a side angle pair, or an angle side pair. I think that's what they called it. She called it, this teacher. And I'd never heard it referred to that way, but I think it's a good way to think about it. An angle side pair. So there's an angle and there's a side. They're opposite each other, aren't they? Do I have another angle side pair? Yep, I got it right here, don't I? So what do I use if I have things like that? Law of sines, right? Use the law of sines. So here, I'm not going to go through and teach it to you from scratch. I'm just going to show you how we'd set this up. Now we're trying to solve for x. I'm a big fan of doing this. If you're whatever you're trying to solve for, I like to put that on the top. That's right. So I'm going to put x on the top, but what do I have to put it over then? If I put x on the top, I got to put x over what? Not just 80. It's the sine of 80. That's right. It's the sine of 80. Don't just put x over 80. Now watch. If I did it that way, if I took the side divided by the sine of the angle, then what do I do with this pair? 12 over the sine of 40. Does it? Yeah, it always goes with the angle. The sine always goes with the angle. You can only take the sine of an angle. Never take the sine of one of the sides. You got it? All right? Doesn't make any sense. And again, I'm not going to teach this from scratch, but always take the sine of the angle. Look, it's really nice having x on the top because I can do one step, get x by itself. And that's to get rid of the sine of 80. Now look, I'm not just trying to get rid of the 80. I'm not just trying to get rid of the sine. I'm trying to get rid of the whole thing. That's an actual number. Put that in your calculator. That's just a regular decimal number. So what do? I multiply this by the sine of 80, and I multiply this by the sine of 80. Now I'm going to put all this into my calculator. So let's do that. It's 12 sine of 80, and divide that by the sine of 40. And hit equals, and there it is. This is the length of a side, isn't it? So what do we do to the length of the side? Round it to the nearest what? To the nearest tenth. That's right. So let's round it to the nearest tenth. So it's 0.4 because that 8 rounds that 3 up to a 4. Everybody see that? 18.4. So x is 18.4. Getting the hang of this? All right. Let's get rid of this stuff just so I have some more room to write. You can always look back on it on the video if you need to. Let's look at this thing. Do we have an angle side pair here? No, I got this, right? But do I have another angle opposite a side and an angle opposite a side? No, I don't. So I can't use that law of sines. But I can use the law of cosines. And how do we know to use the law of cosines? There's basically two ways we use the law of cosines. That's if they give you all three sides, right, and they ask to find an angle, side, 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 or if they give you what? A side, an angle, and a side. So those are situations when we would use the law of cosines. So this situation is side, angle, side. So let's use the law of cosines. I'll write it down so you can remember it. Law of cosines starts off like Pythagorean theorem. Remember that? But then you add a few little things. Minus 2ab cosine of c. Remember, this c has to be opposite. That's the angle. That angle has to be opposite this side. So what's our c in this picture? X is our little c, and what's the big capital C? 103. Okay, and this is our a, and this is our b. All right, so we just plug and chug, right? So we got x squared equals a squared. Doesn't matter which one you call a or b, but I'll just go 13 squared plus 20 squared minus 2 times a, which is 13, times b, which is 20, times the cosine of the angle that's opposite x, which is 103. So there's really no arithmetic on this. There's no real algebra involved. It's just a matter of taking numbers, plug it into a formula, and then using your calculator. Remember I gave you a big talk about this? Yeah. Put a parentheses on your calculator right here and right here. So group all that stuff together when you use your calculator. I just think it's a lot easier, a little safer to do it that way. Let's move this up so I can see it a little bit better. I don't get it. I just don't get it. Why would you? I mean, I just don't understand. So let's do this. 13 squared. Here we go. 13 squared plus 20 squared minus what? No. Parentheses. Parentheses. Okay, then 2 times 13 times 20. You don't, on this calculator, you don't have to hit times. You can just hit cosine 103. Now look, I got to close that 103 in with a parentheses, but then I got to have another parentheses to close that one right there. We've mentioned that many times. All right, so is that your answer right there? Because x squared is equal to all this. So this 685 is all this stuff right here. I got to get x by itself, so I square root both sides. So I take this and I square root it. In this calculator, I just hit the square root of the answer. You've seen that a bunch of times, haven't you? And then equals, there you go, 26 points. What? It's a side, so we round it to 10th, which is 2. 9 rounds that 1 up to a 2, 26.2. And it's exactly what your answer should be. And there it is. Make sense? There it is. One more. Get rid of this just to give myself some room. Alright, this word problem. If you noticed, this word problem is exactly like the word problem that you did in class. I think we went over it the day before we took the test. And I said, even when we went over it, I think I said you're gonna have a word problem that looks just like this on the test. The words might be different, might not be exactly the same words and numbers, but the problem will basically be exactly the same. All right. Let's take a look at it. It says a flagpole in the front of the school. So watch what we're gonna do. You got a flagpole, and you also have ground, don't you? And here's the flagpole right there. Let's get it to touch right there. That's the flagpole. You don't have to draw a flag on it. It doesn't have to be beautiful. It's just a line. That represents the flagpole. This line right here represents the ground that the flagpole is stuck in, right? It says if Jen walks... Now, I put tower. That was my bad on that because I was looking at the problem in the book. But what am I talking about, do you think? 70 feet from the what? From the pole. Okay? So if Jen walks 70 feet away from the pole, the flagpole, and measures the angle of elevation from her position to the top of the flagpole to be that, how tall is the flagpole? So what is she doing? She's right here, right? She's right at the flagpole, and she walks away from the pole. How far does she walk? She walks to right here, which is how far? 70 feet. All right. Now that may not be drawn to scale, and it probably isn't. Because if she looks up 53 degrees, it'll probably be more like that, to tell you the truth. But it doesn't have to be to scale. I mean, you could have drawn this way out here like I did, and it would still work. Okay, you just put the right numbers in, and you're fine. So she walks away 70 feet. Here's the flagpole. She walks 70 feet this way. Then she looks up. She turns around, she looks up at the flagpole, and she measures her angle of elevation to be 53 degrees. What's the angle of elevation? From the horizontal up. That's right. So that angle that she's looking up at that flagpole is 53 degrees. See it? Now we have to make a little bit of an assumption that the flagpole and the ground are perpendicular. So that is kind of an assumption you have to make. What's the question? How tall is the flagpole? So what are we looking for? Are we looking for this slanted line right here? It's not the height of the flagpole. What is it? It's this up and down one right here. We'll just call it x. You got it? That's not so bad, is it? All right, it's just like the one, I think, remember the cell phone tower problem? Do you remember that from the book? We went over it in class. That's why I had tower there, because I was looking at the book to, to word it correctly. And I changed it to flagpole, and then I forgot to change tower to pole. That's why I did that. So now all we got to do is solve for x. Look, it's a right triangle. You've already done a problem almost identical to this earlier in the test. So here's our angle, and we want to solve for x. Which trig function? Opposite over what? Adjacent. Opposite over adjacent, which is tangent. That's right. So it's the tangent of 53 degrees equals the opposite over the adjacent. Multiply both sides by 70, and x is equal to this thing right here. We'll plug that into a calculator and see what we get. So I get 70 tangent of 53 degrees. 92 point what? 9, right? So 92.9. Now this one doesn't say how to round it, but just to be consistent, 92.9. 92.9 what? Feet. Right, that's how tall it is. She walked 70 feet, it's 92.9 feet. And that is Chapter 8 test. All right, so now you should now know how to do every single problem on the test. Now remember, the problems on the test, some of them will be identical. Some of them I'll change the numbers around, something like that. But they'll be the same style, the same exact style. There's not going to be any tricks. I'm not going to throw any problems in there that are any more difficult than the ones that I've gone over right here. All right, so if you study these reviews, you should do fine. Not just study them, but if you understand them, you watch some of the videos, and you do some of the problems. Don't just sit there in front of your computer, just sitting there and staring off into space at your computer screen. Okay, actually work these out. Try it first, and then watch the video. Or watch the video if you didn't understand how to do the problem, and then try it on your own. All right, you've got to do some of that stuff. Be proactive. Be proactive and do what you need to do. All right, so that right there is the Chapter 8 test. Okay?